In Vensim PLE, we select a level variable or box variable and put in a level S for susceptible, another level I for infected, and a third level R for recovered. We then choose a rate variable or a flow variable, click, click, and we call this infection rate. Again, click and click for a rate variable, recovery rate. We then choose auxiliary variable and we put in our constant n for total population, beta, the rate constant for infection, it's a probability, and gamma, the rate constant for recovery. Next, we choose the arrow variable and we tell the infection rate that it depends on S, I, N, and beta. Likewise, we tell the recovery rate that it depends on I and a rate constant gamma. It's a simple first order process. Then we right click on the level S and choose equation, and we populate the units with people. It's just a level, so the units are people. The integration is minus the infection rate, it's an outflow. And we'll start with an initial value of the entire population, which we will make 1 million, just for convenience. Likewise, we right-click on I, choose equation. Again, it's a level, so it's people. The integration is infection rate minus recovery rate, and we'll choose a value of 1. We've got to have at least one infected person for this epidemic to run. Right-click recovery. Again, the units are people. It's a recovery rate that's being integrated, and we'll have no people recovered at the start. We'll then right-click infection rate. We'll make the infection rate dependent on beta, multiplied by the number of infected people, multiplied by susceptible people, divided by n, the entire population. And being a rate, it's people per day. We then choose recovery rate. Again, it's a rate, so the units are people per day. And it's gamma times I, or I times gamma. And finally, we fill in our numerical constants, right-click n, choose equation. We'll assume n is 1 million people, as we said earlier, and the units are people. So that's just the total population size. The probability constant beta is a rate constant, so we'll make that 0.2. It's an arbitrary choice for this example. And the units are 1 over day, day to the minus 1. And gamma is 1 over 15, where 15 is the average amount of time a person is infected for, 15 days. And again, it's a rate constant to units 1 over day. We then choose model settings, and we start at time 0. We end at, well, at the moment I've got it 350, but let's make it 370, just past a year, 370 days. We'll make a fairly short time step, just for accuracy in our computation. Our units of time are days, day, and just ignore the type of integration for the moment. It's called Euler. Finally, we run the simulation, and it's done. We choose S because we want to visualize it, hold the Shift key, and choose I. Oops, I let the Shift key go. Let's do that again. S, hold Shift, I, and also R while we hold the Shift key, and we click Graph. And there we see a graph of all three variables. The green curve shows the susceptible people starting at the full population of 1 million and going down to fairly close to 0. Most people are no longer susceptible. The red curve recovered, most people are recovered, and the blue curve infected, and it peaks at about 111 days and then dies down to nothing as the infection eventually disappears and almost everybody's immune.